The actually split casing design allows removal of the impeller and bearing housing assembly without disturbing suction and discharge piping. Storage and protection. All bumps are sharp tested and ready for operation when delivered. If equipment is to be stored for long periods of time, 6 months or more, should be kept in a clean, dry area, and the following precautions should be taken to ensure that the equipment remains in good condition. Be sure that the bearings are fully lubricated. The shaft should be rotated 10 to 15 revolutions by hand periodically in order to spread the lubricant over all the bearing surfaces. Suitable intervals are 1–3 months. Installation. The pump should be located as close as possible to the liquid supply so that the suction line is short and direct. Location should require a minimum of elbows and fittings in the discharged line before installing the pump, and show that the foundation on which the pump will be placed is prepared well. It has to be sufficiently substantial enough to take the weight of the pump and absorb any possible vibrations from it. The foundation has to be absolutely straight, without any inclination or tilting on any side. The foundation bolt of proper sides should be embedded in the concrete and base plate tightened, ensuring that it is leveled in all directions. Piping associated with the pump must be anchored and supported independently of the pump, and should never put any strain on the pump casing. When the pipes are not supported, the weight is bonded by the pump casing and may cause them to crack or deflect. It is important that the connections be carefully aligned, axially, angularly, and inlet. Suction piping in case of static suction lift condition. Negative suction. The piping run and the connection fittings should be properly aligned and supported separately. The elbow should be of long radius type. All suction piping must be airtight. The suction pipe should be sized to ensure the liquid velocity of not more than 2 meters per second. All suction pipes should have a continuous rise to the pump suction inlet. 6 mm 400 mm slope is recommended. The recommended suction pipe size should be at least 1 commercial size larger than opening of the pump inlet. No isolation valve is recommended. There should be a tapping provided for installing a vacuum gauge and suction light. The reducer joining the straight length of the pipe in the pump light should be an eccentric reducer, with the inclined side of the reducer as the bottom side. The straight length of the pipe after the eccentric reducer should be 2 types of the pipe diameter. The suction strainer must be at least 4 times the suction pipe area, and the mesh sides should screen out solid particles that could clog the impeller. The minimum depth of submerges of the strainer should be at least 4 times the pipe diameter, measured from upper row of holes of strainer. The distance between the bottom of strainer and the floor of the tank should be considered as 2 types of pipe diameters. A stream of liquid falling into the pump near the intake pipe will turn air into the liquid. The supply line should extend down into the liquid. A short elbow should never to bolt directly to the pump suction nozzle. The disturbance in the flow caused by the sharp bend so near the pump inlet may result in noisy operation, loss in efficiency and capacity, and heavy end crust. If separate suction lines cannot be used for each pump, then a tapering header with wide branches should be used. A straight branch header should never be used. Suction piping in case of flooded suction condition. Positive suction. In case the water is being supplied to the suction through gravity, example an overhead tap. A slightly different setup is needed. The elbow should be of standard type or of the long radius type. Isolation valve should be provided in suction line. The pipe supplying from the tank into the pump should have a descendant inclination. The straight run of the piping leading to the pump suction nozzle should be at least 3 times to 6 times the diameter of the pipe from the upscreen elbow. The suction pipe should be sized to ensure a liquid velocity of not more than 3 meters per second. Here should be a tapping provided for installing a pressure gauge in suction line. The reducer joining the straight length of the pipe in the pump line should be an eccentric reducer, with the inclined side of the reducer as the top side. Stuffing box seal connections are usually made from the top of the pump casing. If the liquid being pumped is unsuitable for sealing, then it is preferable to bring fresh, cold water to seal connections from an outside source. Centrifugal separators or other filters may be used to remove aggressive particles from the liquid being pumped, if an outside source is not available. Description of the discharge pipe. The piping run and the connection fittings should be properly aligned and supported separately. Reduce cream on the pump casing. There should be a pressure tapping as close to the pump outlet and before the isolation valve as possible to measure the pump shutoff hit. Concentric reducers are installed in the discharge pipe to minimize friction losses. The check valve used in the discharge should be of non-slam type to prevent reverse flow and protects the pump from excessive back pressure. The isolation valve is provided downstream of the check valve so that these can be taken up for maintenance, priming and starting whenever required. The recommended discharge pipe size should be at least 1 commercial size larger than the opening of the pump outlet. The number of critics and size changes should be minimum to prevent fluid friction losses. Expansion joints may be used only after a careful piping analysis, especially when the discharge pressures are on the higher side. Installation of pump and prime mover. The pump and motor unit needs to be fitted firmly onto the base frame using nuts and bolts before fitting in any pipes. It is essential to confirm the distance between the shaft ends. In the subsequent step, the pump and motor are aligned to the final tolerance using a reverse dial gauge or a laser alignment tool. After the alignment is completed, the piping associated with pump should be bolted. Once this is completed, the alignment should be rechecked and similar readings should be obtained. If this is not the case, then the piping should be investigated and suitable corrections should be made. If this is left unattended, it can cause stress on the pump casing. Misalignment may be the cause of noisy pump operation, vibration, premature gearing failure, or excessive coupling gear. Once the pump and motor have been covered, test the movement manually by rotating it by hand to see if it is rotating smoothly.